Dr. Babu Chakare, sir.
Yes, I am present here.
Hello.
Yes, I am present here. Hello?
Yes, sir. Yeah, thank you. So, dear participants, welcome back for the post-lunch session. The Dr. Babu Chakaria, sir, is going to engage again the second session, data analysis through the SPSS session 2. So, I request Dr. Babu Chakaria, sir, to please take the charge of the session and start. Thank you, sir.
Okay. Please stop that presentation from there so that I can do the presentation.
Yes, sir. We are going to stop. Yes, sir. We are done.
Okay. Okay, let us start. I hope you can see my screen. Can you see the screen?
Yes, sir. Visible, sir. Yes.
Okay. Afternoon's data set, I will just explain. Mainly what we intend to do from this data set is to learn how to perform testing of hypothesis. Of course, there are a lot of conceptual things we need to understand. As and when the things come up, I will go back to my PowerPoint presentation. I'll keep explaining. But please remember that this session will be a little more heavy dose than the morning. So be very, very alert and keep pace with me. In case I'm going fast, please tell me. I will just reduce the speed. Now, I have a data set before you, and it says the table given below contains data from a study on job satisfaction and stress. The sample had 30 respondents, and they underwent a program to overcome stress. Now, this is the data, serial number, gender coded as 1 and 2, 1 for male, 2 for female. Job type 1 and 2, 1 for clerk, 2 for officer. So these are coded variable, please remember. And the last, and they are categorical variables also in the research terms. And the last 3 are response variable. JSS stands for job satisfaction score. Stress and stress after the intervention. Stress A means stress after the intervention. Some intervention was done. First, stress and JSS was measured, and afterward they had a program to improve the situation. Again, stress was measured. So we have 3 response variables available there. Now, these 30 observations are there, which we need to enter on the SPSS screen. So I have entered, say it is like this, but we will recheck whether the variable specifications are correct. Let's come back to this one. Serial number, of course, one thing you can observe here everything is numeric. Okay, all variables are numeric. So here you have everything numeric. And the width 8 is given, almost maximum width required is 2. But I have given 8 everywhere, there's no problem about that. And gender and job type, they are coded variables. So this 1 for male, 2 for female code is given. Job type, 1 for clerk, 2 for officer, that's also given. Okay. Then no missing values, column width 8, everything is centered. Now regarding measure, levels of measurement. Serial number, as you know, it's a nominal variable. Gender also nominal variable. Job type, clerk and officer, there's an order. So I have given ordinal. Okay, and then job satisfaction score, stress and stress after intervention. These three, they are scale variable. You may ask, how are they scale variable? Actually, in research methodology, you have a procedure of scale development. According to those processes, they develop the scale and they have reasons to treat these three as interval level data. So we treat them as scale variable. So the data set is ready. Now, before I go back to questions here, one thing I missed in the morning, and that was, I think that scatter diagram. Somebody asked me for a diagram where 4 variables are there. I said only 2 can be done, but it did not occur to me that that too also have missed somewhere. So I will show you that scatter diagram, how it has to be done. After that, we'll come back to this. Here I want a scatter diagram between job satisfaction and stress. So we'll go to graphs here. Thus far, please remember, morning we were proceeding on these lines. We used to come here, and here charts were there. In that one, only 3 charts were there. What was that? Bar chart, pie chart, and histogram. Now, that is not sufficient. We are going to another part. We are going to graphs here, okay? And chart builder, graphs, chart builder. And here you click OK. Okay, here, come in this menu, scatter or dot. And here, the simplest one, you drag it inside this box and leave it. You can just close this one, it's not required. Now, you want job satisfaction and stress. So job satisfaction, I'm dragging here. See, the finger pointed inside the box, release it there. And then stress also, you drag it here, finger pointed inside the box, release. Okay, then you click OK. It takes some time, please wait, it will come up. Yeah, here there is no pattern visible, they are just scattered. Okay, so this is the scatter diagram which is visible here. If you want, we will do one more where some pattern is available. We'll come to this graph, chart builder. We'll go to some other data. Say instead of job satisfaction, I will remove this one. I will reset it completely. Okay, here, scatter diagram, we'll put this one here. And we'll take stress and stress after intervention. Let us see whether any pattern is visible. Okay, stress and stress after intervention. Here some pattern is visible. Okay, so this is how we create scatter diagram here. Since this is not related to this exercise, I will select everything, delete it, my slate is clean. Let us go back to our present exercise. Okay, now here, separate mean scores for male clerks, female clerks, male officers, female officers in stress. So mean scores in stress of 4 categories. What are they? Male clerks, female clerks, male officers, female officers. Say morning, remember morning we use split file to get separate scores for male and female. Now situation is a little more complicated, is asked. 4 categories asked. Now this category definition, how it comes? one variable responsible for is gender, male, female. Another variable is job type, clerk, officer. Okay, so gender and job type are responsible for this. So we will go and use split file using these two variables. Come here and go to the split file and organize output by groups. One is gender, another is job type. So instead of putting one variable, I have put two variables here. Okay. Now the file is divided between 2 by 2, 4 categories. Okay. Now if I perform mean stress, what will be that? You can come here, analyze descriptive statistics frequencies, and put stress value here and take mean, continue, and close this box. Click OK. See, the output have come. Male clerk, mean stress is 7. Male officer, mean stress is 6.25. Female clerk, mean stress is 6.56. Female officer, mean stress is 8. Each category it is giving separately. Now please remember what I told you in the morning. After using split file, you must always remember to go back there and say, analyze all cases. Do not create groups. If not, all the subsequent analysis will have 4 outputs. To avoid that, give this command. Okay. So now that is nullified. Now the data will be treated as one single set. Now go to the next question. Recode JSS as stated below. That is low grade 54 to 56, moderate 57 to 59, high 60 to 62. Why this is done in this exercise is we have another intention. Later on, when we want to do chi-square test, too many values cannot be entertained. So JSS we are classifying into 3 categories. So only 3 classes will be present so that we can perform chi-square later. That's the intention. Also, we will learn how recording can be done once again. So we'll go there. It is in transform, record into different variable. The data is JSS. Here we will say JSS group. Okay, change. And now all the new values, again we will use only this trick, range. So 54 to 56. And here you say that this is string because I'm writing low. Add. Then next one, 57 to 59. And here put moderate. And then 60 to 62. High. So moderate high. Continue. And click OK. Go back and see the data. So this classification is done. Okay. Next question. Obtain the mean reduction in stress level. Say, look at the data. Say, original stress level was this. After the intervention, stress level was recorded. For some people, it is decreased. Some might not have. Now, the question is, calculate the mean reduction in stress level. So if I want to calculate the mean of something, that variable has to be created first. So there is a provision to create new variable from the existing one. How do you create the reduction? The original stress values minus stress value after intervention. So it has to be created like this. A compute variable. You go to transform menu, compute variable. And here I am writing reduction. Okay. And first you put stress value minus stress after intervention, stress A, and click OK. Go back and see the screen. Say here those are computed. Of course, if you want, you can format it again. You want everything to be centered, center it. And this also center it. And this decimal parts not required. So we will say you have the reduction calculated for every entry. And you need the mean of that. Mean of that is simple. Just come to analyze descriptive statistics, frequencies, and stress, you send it back and you put a reduction. Calculate the mean value. Mean is selected. So mean stress reduction is 0.67. That's the mean stress reduction. Now come to the next one. Test the normality of JSS. It's a morning discussion. I happen to tell you that both for correlation and for regression, the concerned variables should be normally distributed. And then I said, afternoon I will teach you how to perform that test. So here I'm taking one variable to demonstrate the test of normality. So that variable is JSS. How we will test that one? Before that, let me talk about normality part. Say what exactly, let me explain normality first. Say normal distribution, we imagine a bell-shaped curve. Listen very carefully to these concepts. See how this concept of bell shape has come. Many of the variables in nature, like height, weight, everything, when you perform the graph, you will see a bell shape like this. Meaning is this one, near average, the frequency will be more. Okay. When you go to the extremes, very less people are there. Means extremely tall people are extremely less. Extremely short people also are extremely less. And at the average, maximum number of people will be there. So we get a bell shape. Actually, to define normal distribution, there is a mathematical concept called probability density function. But since the audience I am addressing is not from mathematical background, I cannot explain that. So without mathematics, without density function, I will explain normal distribution in a simple way. So first thing you have to remember, it is one among the many standard distributions. Means curves of different patterns can come. Not all variables follow this one. Say for example, age at death. Infant mortality rate may be high. So the curve decreases afterwards. As our age increases, the mortality rate goes up. So it goes a different shape. So this is just one among the many distributions in statistics. Second thing you have to understand, it follows a bell-shaped, and it is centered at the mean value. So mu, we write, means in statistics, mu stands for mean of the population. X bar we will use for the mean of the sample. Similarly, for a standard deviation of population, we will put sigma. And a standard deviation of sample, we will use SD. Okay, here in this shape, it is centered at the mean value mu. And then further, there's a notation to say that something follows normal, some variable follows normal. That notation is this: X curl should be read as X follows normal distribution with mean mu and variance sigma square. In standard deviation square is called variance. And then further, under the area, under the curve, area under the curve between any 2 points A and B represents the probability of it belongs to that region AB, or X falling between A and B, that probability it gives. Look at that sketch. Suppose if I find the area between A and B here, this is the probability that X falls in between A and B. Then total area under the curve will be 1. And area to each side of mu will be 0.5. So this is our general understanding of normal distribution. Associated with this, there is something called standard normal distribution. If X follows normal with mean mu and sigma square, then Z, X minus mu by sigma follows normal with 0 and 1. So this we call standard normal distribution because its mean is 0 and variance is 1. So the curve will look like this. For standard normal distribution, we have tables that provide area under the curve for any given 2 points. So there is some printed table available. Maybe many of you would have used that table when you learned statistics in your class, how to calculate area under that curve. Say for example here, what is the area between 0 and 2? What's the chance that it follows between 0 and 2? So this area, if you look in that table, it will say that that area is 0.4772. So that area will be specified by the table. It enables probability calculations. So we'll go back to our... Yes, somebody has asked a question. Yes? Anyone? Hello? If nothing is there, I'll proceed.
Yes, sir. You
Okay.
can proceed, sir.
Okay. Now, here what we are telling, test the normality of JSS, job satisfaction score. That's the question. How will you test it in SPSS? This is already I told you, this is very essential for before you calculate correlation, before you calculate a regression, because this is a basic assumption. Further, in testing of hypothesis also for t-test, normality test is a must. So everywhere normality assumption comes in many different places, not everywhere, in many different places. So we must know how to test the normality. So I'm going to this SPSS window. For testing normality, procedure is very simple. Come to analyze, descriptive statistics, and explore. Analyze, descriptive statistics, explore. This is the navigation. And here I want to test JSS, its normality. And after that, in statistics, what all we want, okay, descriptive, sufficient. And in plots, You include histogram and normality plots with test. Please remember this. Stem and leaf graph, histogram, normality plots with tests. Okay, and continue. Now you click OK. A long output is going to come. Let us see one by one. Okay, it's coming. So let us look at it one by one very carefully and try to understand. First is case processing summary, 100% processed. So we need not, this is only thing here you have to test is whether 100% processing happened. Sometime by wrong entry, some missing values and other things may create. That has not happened, to verify that only. After that, next table is descriptives. Mean value, confidence interval, trimmed mean, median, variance, standard deviation, minimum, maximum, range, interquartile range, skewness, and kurtosis. This doesn't give much information. Most important aspect is this one, tests of normality. Just like t-test, chi-square test, there is a testing procedure for normality also. Some statistic is calculated and its significance is also done. Here they have given two such tests. One is Kolmogorov-Smirnov test and another is Shapiro-Wilk test. We usually go by Kolmogorov-Smirnov test. And according to that, the significance is 0.097. If it is larger than 0.097, it falls in the acceptance region. How it is, I will explain later when you come to the testing. At present, take it like this. If the significance value is greater than 0.05, the statistic falls in the acceptance region. We accept the null hypothesis. Here, what is the null hypothesis? The given variable, JSS, follows normal distribution. So this is the final thing. And by this, we can conclude that JSS follows normal distribution. But supportive evidence also we may get. Say the histogram, there are distortions, but on the whole, it looks like a bell-shaped curve. And after that, the stem and leaf graph is there. Here that shape, again bell-shaped it should look. And then QQ plot. See, the actual observed values are here. And if it is actually normal, standard normal, then what will be the values were calculated and it is plotted. If it falls nearly a straight line, it falls normal or follows normal distribution. And then the deviations from this line, how much is that? That error, that is calculated and plotted again against JSS. These are the JSS values. These are the errors plotted, deviations. If there is no pattern visible, then it follows normal distribution. Finally, box plot. Box plot means, please look very carefully. This is the minimum value, this line, which I am showing. This is minimum value. And this is the maximum value. Okay. And this one is Q1, first quartile. And this line is Q2, median. And this is Q3. So in short, minimum, Q1, Q2, Q3, and maximum. If this is symmetric, if this is symmetric,
it is on the coordinate.
Somebody's mic is on.
Half an hour to test.
Hello? See, somebody's mic is on. Please switch off the mic.
It's Dr. Amardeep.
Okay, and now, if this is symmetric, well, then we can conclude as it is normal. So these are the things by which we can come to a conclusion that a variable is normally distributed. Now we'll go back to the next question. Test the hypothesis that mean JSS, job satisfaction score, is less than 60. So hypothesis testing and the background knowledge is required. Now I will take a few minutes now to explain to you what is hypothesis testing, how it proceeds. Now come to this, I'm going to do it a little fast. Of course, I sent a video, but a few people have actually seen that. So here in brief, I'm going to explain again. First of all, we must understand why testing is needed. I'll ask a question initially. Say, for example, I am conducting a study on job stress. I have taken a sample from banks, and I have calculated the mean stress level of females. That was 7. And I have calculated mean stress level of male employees. That was 6. Females was 7. Males was 6. Can I conclude immediately that females are more susceptible to stress? If yes, why? If no, why? Yes. Whatever you think, you just put it across. Is the question clear? Yes or no?
Yes, sir, clear.
Question is clear. Okay. Answer then. Can I conclude that females are more susceptible to stress?
No.
From this? No. If no, answer is correct answer, we cannot conclude. Why then? What's the problem?
It can be by chance also.
It is by chance. Okay. So there is something called fluctuations in sampling. So we need to know that concept clear. I will explain through a very small example what is fluctuation in sampling. Just imagine there's a population. Only 6 entities are there. Their values are 2, 6, 3, 5, 8, 9. Its mean, population mean, total 33 by 6, 5.5. Now I am going to take samples of size 2. And the first sample by lottery method came to be 2 and 3. I calculated the mean, it is 2.5. I took another sample, usually it is not taken, but for demonstration, I took another sample. By chance, it happened to be 8 and 6. Total 14 by 2, mean is 7. Third sample I took 5 and 6, 11 by 2, mean is 5.5. Now observe, first sample tells me that mean is 2.5, which is very low compared to the population mean. Second sample says that mean is 7, which is much higher than the population mean. Third sample says that mean is 5.5, which is exactly same as the population mean. So what we conclude? Different samples gives different estimates. This is known as fluctuations in sampling. Now, if this is happening, now my problem is there. We'll go back to the problem I posed. I took a sample and I found that stress level of ladies are more than gents. Now, whether it has come because of fluctuation in sampling or is a reality, what to do is a problem. So this problem is there in the mind of every researcher. How shall we overcome the problem of fluctuations in sampling? So the approach to solve that problem is there is something called testing of hypothesis, a method by which we may determine with certain degree of confidence, please underline that word, certain degree of confidence, as whether the information is due to fluctuations in sampling or not. So even after testing, you cannot be 100% sure that what I have observed is a true reflection of the population. No. Only with certain degree of confidence, I can say that it is a reflection of the population. So there is no 100% assurance coming from testing also. There is certain degree of confidence there. Chance analysis, actually. Through chance analysis, we will come to a conclusion. I hope you understood what it is. Now, we will understand the terms and terminologies one by one. Then we will collect all the terms together and understand the logic. Now, first term is null hypothesis, a neutral hypothesis, which is stated with the intention of nullifying it later. So, example, webinar is equally effective as classroom teaching. It may be true, may not be true, but it's a neutral hypothesis. I am not favoring webinar, I am not favoring classroom teaching. I am neutral. So this is a null hypothesis. Now, alternative hypothesis. Anything contrary to the null is alternative hypothesis. Now, example, first one, webinar is better than classroom teaching. Another, classroom teaching is better than webinar. Another, the two methods differ in efficiency. Say, three different ways I can state the alternative hypothesis. So the first two, I am favoring one. So therefore, we call it one-tailed test. Why it is, we will show you later. At present, I am giving the example in advance, we will see later. Now, second one, I am not specifying both options are open. The methods differ, means they are different. I am not saying which is better. So that leads to two-tailed test. Though through testing, we accept one among null or alternative and reject the other. See, the null hypothesis we denote by H0, alternative by H1. So one will be accepted, other will be rejected. So this can be the situation. Say H0 may be true or it may be false. And these are the two status possible. We may reject H0, we may accept H0. Say H0 is true, but if we are rejecting, we are committing an error, which we call type 1 error. H0 is false, we reject it, so it's a corrected decision. H0 is true, we accepted it, corrected decision. H0 is false, yet still we accepted it, false decision. That is called type 2 error. So rejecting null hypothesis when it is true is known as type 1 error. Accepting null hypothesis when it is false is known as type 2 error. Now, the probability of type 1 error is known as level of significance, which we have to specify in advance. Many of the people in social sciences usually fix alpha as 0.05, means he is ready to tolerate 5% error. Some people fix it as 0.01, means 1% error is ready to tolerate. Before you start the procedure, you have to fix this one. Then the probability of type 2 error is denoted as beta. And 1 minus beta is called the power of test. Or in other words, 1 minus beta is the probability of correct decision. So this is used to determine the sample size. Of course, sample size determination, there are a number of methods there. And power of the test, using that one also it can be done. This is one of the ways. Usually after determining the sample size, then power does not come into discussion, but alpha remains till the end of the testing procedure. Test based on normal distribution. Now let S be a statistic. Statistic means a function of sample observation, or example arithmetic mean. X1, X bar is X1 plus X2 plus Xn divided by N. So it's a function of sample observations. Now assume that this test statistic follows normal distribution with mean mu s and sigma s. If that is the case, and why we are using is, there is something called central limit theorem, which says if sample size is large, okay, irrespective of the parent population distribution, the mean can follow normal distribution. So such a system thing exists. So we use this technique. So here in this case, we can also calculate standard normal by subtracting the mean and dividing by the standard deviation. And in this process and logic of testing, say here, consider H0 and H1. This will suggest an S. For example, consider the problem of jaw stress. If mu1 is equal to mu2, say for example, we are comparing male and female. Okay, so null hypothesis will say that there is no difference between male and female. That means mean of males will be equal to mean of females. And alternative, we are fixing it this way, they are not equal. Then our interest is in the difference between two sample means. So our S will be X1 bar minus X2 bar. Now we can convert this into standard normal units. So from this S, subtract its mean, divide by its standard deviation, pooled standard deviation. And using this in null hypothesis, we are assuming this to be equal. So mu1 minus mu2 will be 0. So that goes, we get Z like this. This can be calculated. Of course, we are assuming the standard deviation is known. That is one problem here. On calculating this, if the value is extremely large or extremely small, there are two possible conclusions. H0 is correct, but a rare event happened. Say, look at this one. Large value will be coming to the right end. And that chance is very small. Area is small there. Small value comes to the left end. And that chance also is small. So when we have calculated that Z, if it falls somewhere here, then a rare event has happened. Or if it falls here, a rare event has happened. That is the meaning. Now, H0, otherwise, H0 itself may be incorrect. Say, rare event can happen, therefore it can fall. But the H0 we have used to calculate this, if it is wrong, the curve will be somewhere else. That is another possibility. But we will conclude it this way, since rare events are rare, it is more logical to conclude that H0 is incorrect and reject H0. So usually using this logic, what we do, if a rare event happens, we reject H0. Okay. Now, process of deciding the extreme values. Z follows standard normal. Extreme values falls at the tails. Consider the areas at the tails equivalent to alpha by 2. Get the corresponding Z values. The region between them is acceptance and the other are rejection. Say, consider this one. Say we have divided that alpha into two parts. Alpha is 0.05 divided by 2, 0.025 here. So this will be 0.475, this will be 0.475. Total of these four figures will be 1, total probability is 1. Now the cutoff value we can get from the table. For this 0.475 cutoff value from the table will be 1.96. Similarly, this will be minus 1.96. From the table you can get it. And the region across this will be acceptance region, and what lies beyond is called critical region or region of rejection. So extreme values, if it's happening, we are rejecting. This is the procedure usually taught in the classroom. Even the video which I have sent, we have used this procedure. Now decision rule. Say if it is a two-tailed test, like mu not equal to mu naught, then alpha is divided by 2, there will be 2 rejection region, critical regions. If it is one-tailed test like this, mu is greater than mu naught, only right tail will be there. So this will be rejection region, the rest is acceptance. And mu less than mu naught, if it is there, then we are concentrating on the left tail. So remember this one, not equal to, it will be two-tailed test. Greater than, it will be right tail test. Lesser than, it will be left tail test. So this is decided by alternative hypothesis. So this critical region, acceptance region, everything comes out of alpha value and also the nature of alternative hypothesis. Now further, logic of acceptance and rejection, acceptance. So in the yesterday's video which I have sent, I have explained only to the previous slide. Now we are not using that procedure in software when we use. So in the software we are using something different. So whatever I have explained, see alpha is here, this will be acceptance region, this will be rejection region. Suppose I have calculated a Z and it falls here. Okay, so if the calculated Z falls in the acceptance region, area to the right of Z will be greater than alpha. Can you see this? This is alpha. Z falls in the acceptance region. This area, it will be greater than alpha. Can you see that? See, this area will be greater than alpha. So what we do in the software, SPSS, they calculate this statistic and area to the right of the tail, that is calculated. So then decision rule will be changed like this. Thus, if the area to the right of Z, that is called significance or p-value, some of the software call it p-value, is greater than alpha, then Z falls in the acceptance region. Accept H naught. Similarly, rejection. Say alpha is here, this is the setup we have. Now, calculate Z falls here. Okay, so if the calculated Z falls within the rejection region, area to the right of Z will be lesser than alpha. Say it falls here, so area will be this much, it is lesser than alpha. So thus if the area to the right of calculated Z, that is called significance, is lesser than alpha, Z falls in the rejection region. So in our SPSS, it will calculate Z value, it will give you, it will also give significance. If that significance value is lesser than 0.05, we reject. If it is greater than 0.05, we accept. Okay. Now, procedure of testing, it is like this. Specify the level of significance, alpha, and specify the null and alternative hypothesis. Calculate the test statistics. You need not calculate, SPSS will calculate and give you. Obtain the area from the calculated value to the tail of the distribution. For two-tailed test, 2 times that area. Okay, this is called p-value or significance. Reject X naught if significance is less than alpha, accept otherwise. This is the simple procedure we are following. See, I have explained everything using normal distribution, but there are tests based on t distribution and chi-square, but same logic applies there also. Okay. Now, t-test for small samples. In normal test, it is assumed that statistic S follows normal distribution. To assume that one, we need a large sample. However, small samples, this is not a good assumption. When sample size is small, t-distribution is more appropriate. T-distribution also is a bell-shaped symmetric curve with parameter nu, degrees of freedom, which in turn depends on the sample size. For samples more than 30, t coincide with normal curve. So more than that, you may go to the z-test. And the first test which we have is test for mean. So here the situation will be like this. There will be a specified value for mu. Alternative can be one among these three. And t is calculated by this formula. And here the standard deviation is calculated by this formula. You need not bother about this because SPSS will calculate all those. And these are the notation explanations. So there are limitations. If standard deviation of the population is known, more powerful z-test is available provided n is greater than 30. Test is accurate if the population is normally distributed. Means before performing t-test, you have to perform the test of normality. As examples, hardness of water from Kolhapur district is 200. Alternative, hardness of water from Kolhapur district is more than 200. Such a situation is usually this 200 and all, they are standard values. So if you want to compare something with the standard value, usually the test for mean is used. Now we'll go back to SPSS. Now the question here is, test the hypothesis that mean is less than, mean JSS is less than 60. So testing procedure is very easy. Here you have to come to analyze descriptive statistics. Compare means, one sample t-test. Analyze, compare mean, one sample t-test. So JSS is the thing. Test value here it is 60. Okay, and just click OK here. Now here this is the table. Here t value is minus 4.883. Say here what we said, it is less than 60. Okay, so what is, they have given two-tailed significance. What is the significance given? 0.30, but beyond that there will be digits. They are displayed only 0.30. If you double click it, after some zeros you will see some numbers. Anyway, this number itself is less than 0.05. But remember that alternative hypothesis is it is less than 60. So we need one-tailed significance. So this 0.30 something divided by 2, that will be 0.30 something. And that will be lesser than 0.05. So it falls in the region of rejection. We reject the null hypothesis and we accept the alternative. That means JSS is less than, mean JSS is less than 60. So that is how we conclude. More important is how to read the answer from the output. SPSS will give you a lot of output. You must read it correctly and interpret it correctly. That's what we need to learn. Okay, next question. Test the hypothesis that mean, that was over, sixth one. Test the hypothesis that JSS differs between male and female employees. Means job satisfaction is different for male employees and female employees. What will be the null hypothesis there? H naught will be mu1 is equal to mu2. Mu1 is mean JSS of male, mu2 is mean JSS of female. Alternative will be that mu1 not equal to mu2. It differs. Okay, how do we test? Come here, analyze, compare means, independent samples t-test. And here you put J, what was that? JSS only, right? Yeah, JSS. Okay, grouping variable is gender, male and female. And define groups 1 and 2, 1 for male and 2 for female. Why this step is required is there may be categorical variables with more than 2 categories. So in t-test we can compare only 2 at a time. That is why this option is there. So click OK. Now a still bigger table has come. Please listen carefully to how to read the answer, because getting output from SPS is easy. You must know how to read the answer. Say, please remember that for T, there are 2 formula. Okay, assuming equal variances, there is one formula. Not assuming equal variance, there's another formula. Therefore, there are 2 T values given. So this assumption is a first row values. This assumption is the second row values. Now, which row we have to refer? For that, here something called Levene's test for equality of variance is there. See what I am showing, you see that box, Levene's test for equality of variance. This box, it has a test statistic F. It has some value, don't bother. Rather, look at the significance. 0.794 greater than 0.05 falls in the acceptance region. We accept the null hypothesis. But then what is the null hypothesis here? Variances are equal. So that is accepted. That means we will be referring only the first row. Clear? Now here the T value 0.177, very small thing. And two-tailed significance we want, it differs between the male and female. So two-tailed significance only is given. That is 0.861 greater than 0.05 falls in the acceptance region. We accept the null hypothesis. That means there is no difference between male and female as far as job satisfaction score is concerned. Okay. Now next question. Test the hypothesis that program, 7th question I'm reading this one. Test the hypothesis that program of stress reduction was effective. See here in our data, please remember that stress before the program, stress after the program. So this is called paired samples t-test. Its background I can show you, just 1 minute. I forgot to show the previous one. Anyway, this is the thing. I'll just explain the background. Say, consider the case where observations occur in pairs. For example, body weight before and after weight loss program. Okay, so here we consider difference. So null hypothesis will be that there is no difference. Alternative can be one among the 3, not equal to 0, greater than 0, lesser than 0. And the T used to calculate is this, degrees of freedom is this one. And these are the symbols that are used. D bar is a mean of the sample difference. Okay, and SD is its standard deviation. This is the formula to calculate that. assumptions are that independent variables must be continuous and sorry, dependent variable must be continuous. That is important. And observations are independent of one another. And third, dependent variable should be normally distributed. So how to verify normality? Already I have told you. So we'll go back to this one and perform that. So whether that stress reduction program was effective, that's a question. So we go to this one. Compare means paired samples t-test. And here one variable is old stress, another variable is stress after intervention, stress A. Then click OK. It gives the output like this. So the mean difference is 0.667. Okay, that is there. And corresponding t value is 6.021. And significance is what is our alternative null hypothesis? That there is no difference. Alternative hypothesis, how will you decide? You have to read the question carefully. Does the program that stress reduction program was effective, means greater than 0. So it is one-tailed test rather. So here you have to read the answer like this. This two-tailed significance is given, divide by 2, 0.30, something will come again. Whatever it may be, it is lesser than 0.05. This falls in the rejection region. We reject the null hypothesis. Therefore, we accept the alternative and conclude that the program was effective. So with this, I have completed the t-test. Now the next 3 are chi-square test for independence. So we need to know the background of that. We'll go to the PowerPoint. Listen carefully to this one. See, usually 2 attributes will be there. Here I have taken the example of education, low, moderate, high. Standard of living, low, moderate, high. And the joint frequencies we need to obtain. Okay, here 7 means there are 7 people with low education and low standard of living. This 4 means there are 4 people with moderate education but with high standard of living. This is the bivariate frequency table. This data we need to obtain. Okay, after that get the row totals. So here I obtain the row totals. So whatever is in the gray cell, they are the observed frequencies. Observed frequency means this has a notation, please remember. This we call O11, O12, O13, O21, O22, O23, O31, O32, O33. Okay, observed frequency in the corresponding cell. Then row totals we'll get the column totals and we'll get the grand total. Okay, after that, the null hypothesis that 2 attributes are independent. Always in chi-square test of independence, this is the thing. Alternative will be they are not independent. So Ij, observed frequency in ijth cell. Now we have to calculate something called expected frequency. And that formula is this: ith row total into jth column total by grand total. With this, we get a similar table. Okay, and after that, this formula is used to calculate the chi-square, and the degrees of freedom is by this formula: C for the number of columns, R for the number of rows. Okay, and the chi-square distribution shape is like this. It is not symmetric about the origin. It is only to one side, and it is not a symmetric curve also. It has a long tail. Critical region will be here. Okay. After we calculate this chi-square, what do we check? Whether it falls here or whether it falls here. If it is lesser, significance is lesser than 0.05, it falls here. If it is more than 0.05, it falls here. Acceptance region. This is the test we are going to perform. And it has assumptions also. Let me do that because that is very important. Data in the cells should be frequencies only, and categories of the variable are mutually exclusive. So the divisions, low, moderate, high, should be very perfect. Okay, and each subject must contribute data to one and only cell. Then the study groups must be independent, and value of the expected cell, the value of the expected cell should be 5 or more in at least 80% of the cells. So EIJ, when you calculate, it should be greater than 5 in at least 80% or more cells. That is the thing. And this I will come back later. Now I will not discuss. Now, the first question here is, test the hypothesis that stress is independent of job type. Often we say that higher the level of your job, more stress. That is what we want to test. Stress is independent of job type. So procedure is quite simple. Just come here, analyze descriptive statistics, and cross tab. So stress actually will take this stress in rows, job type in column, and click OK. So, sorry, we forgot to do one more thing. 1 minute. We will do that again. After said this one more thing you have to do, go to statistics, chi-square. This we forgot. And click it. So this time, chi-square test, Pearson's chi-square, other things you can ignore. And the value, chi-square value 3.3 you are getting. And two-tailed significance is given, you divide by 2. So 0.34 something. So that will be more than 0.15, greater than 0.05, falls in the acceptance region. Null hypothesis accepted. Null hypothesis accepted means the two attributes are independent. Stress and job type are independent. That is this data saying. And the next question, does the hypothesis that stress is independent of job satisfaction score? Come here, analyze descriptive statistics and cross tab. Stress is independent of job satisfaction group. So we will use job satisfaction group. That is why we created that. This is already selected, chi-square. And in this chi-square value pretty high, 13, and significance, two-tailed significance 0.03 divided by 2.015. It is lesser than 0.05. That means it falls in the rejection region. Null hypothesis is rejected, alternative is accepted. So what was null hypothesis? They are independent, that is rejected. So stress and job satisfaction are connected. That is what it says. And the next one, does the hypothesis that stress reduction is independent of gender? Stress reduction is independent of gender. So stress reduction we have calculated. Whether any connection with the gender that is asked. So we have to come here and cross tab, remove this and remove this also. Gender and stress reduction. And the other one is selected already, you can see here. So this time the value is 0.05, very small. 0.975 divided by 2, it will be near 0.5. It's much bigger than 0.05. Falls in the acceptance region. Null hypothesis accepted. That means stress reduction has nothing to do with the gender. That's the conclusion. Now, I think we have completed all this exercise, but I want to talk to you something further. Say, all those who have attended these sessions, by this one workshop, you cannot be anywhere. For example, I have covered only t-test and chi-square. It has normality assumption. If normality doesn't work, you have to go to non-parametric tests. So you require much more knowledge. You need to know which book you should be referring. Say, here, I'm giving you a list of references, which will help you to decide. And even though in classrooms, usually we teach Z-test, T-test, chi-square test, and some non-parametric tests we may teach in the classroom. But your research problem may have some variable and some particular analysis which will not fall in any of this category. It is really happening. Then you may have to use some other tests. So one such book which you can use to decide which test to apply is 100 Statistical Tests by Gopal Kanji, the SAGE book. Okay, it's available in our library. All these are available in our cyber library. Then another book is Statistics in Nutshell. Those who don't want to read too much, quickly want to grab, that can be used. Then Introductory Statistics, Sheldon Rose. Actually, it is a very good book. The author is very famous, Sheldon Rose. In statistics, his books are very well accepted, standard books. And regarding learning SPSS, you can use this fourth book, Statistical Methods for Practice and Research. A Guide to Data Analysis. The Indian authors, Ajay Gaur and Sanjay Gaur, they have written. And the fifth book, SPSS for Windows Step by Step, Jor and Mallory, that also is a good book. And SPSS for Psychologists, that's also a good book. So the last three are books of SPSS, and the first three are for books for statistics. I think I'm just in time and I'm through, so you can ask your doubts or questions.
Yes, sir. Thank you. Now I
Sir, it was a very good presentation. I'm speaking from Pune, sir.
Okay.
Sir, can you just highlight about the log probability graphs that can be used for finding out standard deviations?
Non-probability graph.
Yeah, log probability scales that we use normally for finding out the standard deviation, and then we utilize that standard deviation in Hatchcote equations to describe the size of the particles in pharmaceuticals.
Non-probability graph for, I'm not getting the question correctly.
Sir, we use
Can you
log
repeat the
probability.
question?
Sir, what we are doing is that we find out the size of the particles of a powder.
Okay.
And the distributions are not normal. They are skewed distribution.
Okay.
So for finding out the 50% of the size of the particle, we use log probability scales.
But there is stop. 50% of the size of the particle to find means what?
Yeah. 50% size,
I have
because
not understood that concept.
50% because size of the particle is varying. It varies from that of the 50 micrometer to 400 micrometer. So it becomes very difficult to find the exact size. So for that purpose, we find out 50% size. And on the
size, what do you mean is you are finding median.
Frequency distribution.
You are effectively finding median.
Correct, median.
Okay. Go ahead.
And then we submit that data into the log probability scales by plotting frequency distribution.
Non-probability scale means what?
So there are some graphs, we call that as a log probability graphs. And we get straight line.
I'm not following from here, actually.
Okay, sir, then I will write to you separately then.
Yeah. You send it separately with full description, because
Yeah.
people who are asking me from a particular area,
Yeah.
don't use your terminologies, come to the general terminologies and refer back to me.
Yeah. That I understood, sir. I understood.
Yeah.
Okay.
Okay.
Yeah, thank you, Nalawde sir. Any other participants want to raise any doubt? Yeah, somebody want to ask the question? Yeah, I think sir has cleared all the doubts. Because of that, there is no more questions.
Okay, then we'll close down that, no problem.
Yes, sir. Again, I'll once again I'll request to all. If anybody have the question, please raise. Otherwise, I'll take the charge and I'll try to
See,
wind
one
up the
thing
meeting.
I'll just remind the participants, whatever you learn today, you have to practice immediately, otherwise you will forget within 1 week. So please download the SPSS, install on your machine and practice. Or if you have your college, no problem, go there and practice. But it is very essential that practice is needed, and whatever you have learned today is sufficient as a start point. Further things, I have given you the books. A lot of videos are available in YouTube. You can pursue on your own. You don't require anybody else to come and teach you. What I have done is I have given you the start. That's all. Okay.
Yes, sir. Very true. The practice makes the man perfect. So accordingly, whichever you have taught us in these 2 sessions, will practice and will try to cover all the whichever doubts we have in our mind. And for the research, we are going to use the SPSS. So now, taking this opportunity for the last session. Now, Jakaria sir has taught us very clearly how we are supposed to use the SPSS, and in our research, which are the questions we have in our mind, how we are going to cover up or the analyze. In this second session, he has taught us how to use the scatter diagram. Its different graphs also he has taught. For this, he has used the ready-made data set. Later on, normal distribution, hypothesis testing with testing process clearly mentioned. So has given the fluctuations in sampling, types of error, process of deciding extreme values, and its logic of acceptance as well as rejection, which is the most important part. One should aware that what is the logic behind that, how we are supposed to either accept or the reject. So he has already clearly mentioned this. He has explained the t-test as well as the chi-square test. List of reference book, which is the most important. Later on, if somebody want to try or want to take the more information or the knowledge, so in that case, the which books to be referred, that may be the big question in our mind. So from participants point of view, this is the very good stuff you have provided, and that can be more useful to all the participants. Hence, on behalf of the organizing committee, cyber, and all the participants, from my bottom of hearts, I would like to offer my vote of thanks to Dr. Babu Jakaria sir, and in future also we need the same type of the cooperation from your side, sir. Thank you, sir. Thank you once again.
Thank you so much.
Hello.
Yeah, yeah.
Yes.
Sir, just little instructions.
Hello. Yeah, yeah, ma'am. Please.
Hello.
Uh, you're audible, ma'am. Audible.
Hello. Good evening, everyone. We finished with the 12th session today. Tomorrow we begin at 10:30 again. At 10:15, I want you all to log in. Tomorrow only we have one session of Raghavendra Raju. It is on report writing. How do we? That is the last step of research. The report writing, how we do it, and what is plagiarism and all that. A brief note will be told about it, and after which later second session will be on meditations by Prerna and Swapnil Daide. They will be doing that, and after that we will have a very brief validatory function, and after that you will be where you all will be sharing your feedback and all. Any of you who are interested to do the give a feedback about this, you have a feedback link also. Plus, you will have to express yourself. Those of you who want to express about the FDP program can do so. And after that, you will be having your test. So based on your test and your attendance, plus you have to fill a feedback link in the Atal portal also. Only then you all will be getting your certificate. Take it and note. Many of them could not join my FDP. It was only because they have not done the registration completely. They did the registration, but they didn't apply for our FDP. That is how they have lost, and many had joined on the first day. And gradually, since the registration numbers were not there, they have left the meeting. I hope you have done today's presentation attendance. Attendance, fourth day ka attendance we had sent. Day 1, day 2, day 3, and day 4's attendance today again. Those who had missed it, now I would not be entertaining any other calls or WhatsApp chats saying that Madam mera ye nahi hua, wo nahi hua. I want you all to please cooperate. Tomorrow is the last day. We should go with good memories. So I would request you all to please share your feedbacks. Those who are interested either to express, we'll give them a chance in the validatory function. Tomorrow you will be having exams also of 25 questions, multiple choice questions. This will be based on what our resource persons have spoken to you only. We are not going to give you any tough questions and all. Whatever has been asked about it, I'm sorry, whatever has been discussed with you all in this 14 sessions, not 14, 13 precisely, because 14th is only on meditation and stress management. So, and I'm uploading the PPT now after some time, after this session, because we are waiting for the PPTs of other resource persons also. Whatever is available right now, I will be uploading it and will be sharing the link on the WhatsApp or and even on the mail. Kindly see to it, and whichever PPTs would like to have, you all can go in for that. Is it okay? Sharing the recording, I am not that technically sound, but I will still try. We'll send you the link so that you can have the recording. We will be doing it in a short process, but right now, immediately, whether I'm able to do it or no, I will just check into it. Because our technical team also will be leaving by 5 o'clock, so I don't know whether it will be possible or no. Okay, we will be mailing you the links for PPT as well as recording also. Any questions from your side? Any doubts?
No doubt, ma'am. No doubt.
I hope you all had a good time with us in FDP. I know the beginning, the day inauguration started well, but due to some technical problems, we had a 10 minutes delay. But we have seen to that कि हमारा time management के हिसाब से सब report time on time हुआ है हमारा. So it is just because of all your cooperation and the help of our resource person. They were also on time. Our session in charges They were also on time and they have done their duties very well. So thanking each and every one of us, let's clap for ourselves and part for today. See you all tomorrow morning by 10:15. Thank you so much. If you all have any doubts, fine, I'm ready to discuss with you. Otherwise, we say bye for now.